So when we are looking at word problems, we're going to be looking at the same key terms that we used last trimester. The difference is that now we are talking about a system. So what is a system? What did we say a system was?
Like
two variables and two equations. So now instead of the word problem translating into one equation with one variable, it's now going to translate into two equations with two variables. All right, we're going to use all those same rules from first trimester. I actually already have linked to Canvas that table from first trimester that had, you know, like sum is addition, more than, increased by, and it would give you all those key terms for each operation. So if you say, oh my gosh, I forget all of these things, those are linked onto Canvas for you to access and look up as well. All right? The other piece that's going to be new today is that once we write the system, it's going to be our job to decide how to solve it. Right? We have been looking at problems and saying, solve these following problems by elimination, and we just solve them by elimination. Okay, today you're going to have to make that decision on your own. So let's talk through some of those concepts we've been looking at as we go into each topic. If we want to solve by graphing, okay, so if we're looking at a system and we're going to solve it by graphing, what are some characteristics or some things that that system has to have for us to be able to solve it by graphing?
2 points.
I mean, we're going to have to find those points, but think even simpler like that. Like then when you're just looking at the equation to start with. Yes, Sam? We want it to be in the form y equals mx plus b. In fact, we want both of them to be in that form.
Okay.
Right? So if we're going to go with graphing, we could either do the work of solving them both for y, or use another method. So if they are both solved for y, okay, that might be a good cue that maybe we could or should consider solving by graphing. Now, this is a pretty obvious piece in here that students don't even think about, but when I write it, they're like, oh yeah, duh. You're probably going to need a graph to solve it by graphing, which means if you don't just happen to have a graph lying around, you might not want to solve by graphing. Who wants to draw out the tedious graph and make all the bars if you don't have a graph?
Not me.
Right? Not me either. I don't really like drawing those graphs. Okay, but if I have a dry erase board or if I have some extra 10 by 10 graphs, well then no problem. Okay? Our second option is that we can solve by substitution. What did we need to be true if we were going to solve by substitution?
The elimination.
There has to be an empty number, like the variable one.
Can you do elimination?
So elimination is going to be a choice we're going to get to in a minute. Okay, but for substitution, we need a variable with a coefficient of 1. But even more importantly, we wanted that variable with a coefficient of 1 to be by itself. So we wanted one equation to either say x equals or y equals. Right, graphing, we need both of them to be solved for y. Substitution, we would be okay if just one of them was solved for y or solved for x. Okay, then our last option, which we've been looking at earlier this week, is the elimination option. What did we sort of need, or what did it look like for us to maybe consider solving by elimination? Okay, so we want that coefficient to be the same, but we at least didn't know that we could work around it if they weren't the same. So what else did we need it to look like?
One needs to be negative.
We also need to do that, but we can force that to happen if it doesn't
It
happen.
has to be a negative and a positive.
That's what he was saying, right? We can force that to happen if it's not the case. But like, what if we were given, what if I wrote this down?
Oh, one has to be in Y form and one has to be in like.
This would be substitution. Why would this not be elimination?
Because you.
Oh, you need to have it solved for Y.
Okay, so that y is by itself. What if it said this?
That's when you could.
You need to have it
That's
solved for
still
Y.
not. So that's still substitution.
You need
It's
to
still
have
not
it-
set up for elimination quite. Why not?
So you need to have it solved for Y or X.
No, because the y isn't above the y and the x isn't above the x. They have to be in the same column.
We needed these to be like that stacked look.
Stacked, yeah.
Now, again, in all of these situations, right, you're all telling me true statements. Okay? But this is the critical piece because the rest of the multiplying and stuff we can take care of after that. Now, it's also going to be the case that I might look at a problem and choose to solve it by substitution, but someone else might look at a problem and choose to solve it by elimination. We are totally capable of rearranging a problem and making it look like whatever we want it to look like at this point. We're actually pretty darn good at it, right? So if we solve this, we could subtract that 6x and move it over there and make it be elimination if that's the route we chose to go, right? So some of this is just about what picking what you prefer and just going with what you see to do first, all right? So let's take a look at this first problem. Okay, so number 1 says find two numbers whose sum is 7 and whose difference is -3. Find the numbers. So with any story problem, we've said it's easier to go a small chunk at a time. Don't try and do it all at once. That's too much for your brain. So what is this problem asking us first? It says find two numbers. What does that mean?
X or
X and
Y.
y.
Right? We need to find two numbers. So we have x as a first number and y as a second number, right? I'm just translating everything that I sort of see as I read. And hoping by the time I translate it all, it gives me a system I know how to do something with. Whose sum? What does sum mean?
Add.
Add. So what is it telling me to add?
7.
Two numbers. And my two numbers are x and y.
Yeah.
I'm adding two numbers. Okay. What does is tell me to do?
So
Subtract.
Equals 7. Right, the word is means equals.
Then subtract 3.
Okay, hang on.
I think.
This is a word that's going to be really important, even though it seems very minor. I'm not talking in the math world. I mean just in English structure, grammar, rules in general. What does the word and mean?
It's like
Also.
I mean also, but what does and allow us to do with our sentence structure?
say more.
Make it longer.
What do you mean by make it longer?
Like you could say, my name is Samuel and I like pizza. Or my name is Samuel, I like pizza.
Okay, so it's allowing him to take two sentences
And combine them.
and put them together. So this is exactly what's happening. Okay, this is actually two sentences that we've tied together into one. Okay, and in the math world, a sentence creates an equation. So we need to recognize that this and is really starting a new sentence.
So it'll be Y.
Okay, and we're putting those together. So the subject is the same. Right? Find two numbers whose difference. So what does difference mean?
Subtract.
Subtract. And what do we want to subtract?
Two numbers.
Two numbers. So now we're going to do x minus y
Equals -3.
equals -3. Right? That and says go back to the exact same subject. What was the subject? Two numbers. So are we okay with these two equations? We see where they came from? Now our job is then to decide, do we want to solve this by graphing substitution or elimination.
Substitution.
Okay, so substitution says that we have one of them that says x equals or y equals.
Elimination.
Do we see either of these equations saying x equals or y equals? No. Elimination says that we see that they're stacked. Do we see them being stacked?
Yes.
Yes. So this is probably best to go with elimination. Now, could you solve one of them for one of those variables and go with substitution?
Yeah.
Absolutely. I just don't think it's the choice the majority of us would make. Okay, so if we look at this, do we see a variable with a matching coefficient? Which one?
X.
Actually, both of them, right?
So you could cross, yeah.
So we could go either way. I would choose to go with the y's. Why would I choose to go with the y's? One's positive and one is negative, which is our other requirement. That way I don't have to multiply through by the negative one. Okay, so I'm going to add these two things. What is x plus x?
2x.
2x. What is y plus a negative y?
Negative.
They cancel.
Oh, yeah. Forgot about that.
What is 7 plus a negative 3?
Now we divide.
And this is something we can then divide and solve.
Then we have to plug it back in.
Yeah, we're not done yet, right? So we gotta plug it back in and find the other
Can you
variable.
plug it back into the top, please?
Sure. And what variable are we gonna plug this in for?
X.
X. So we'll say 2 plus y equals 7. We'll subtract that 2. And we'll get y equals 5.
Huh? Sorry. I didn't-
So it's 2, 5.
Now, let's talk about that for a minute. I mean, if we're just writing down the answer, our answer is 2, 5.
Mm-hmm.
But,
Something wrong with that?
well, let's think about what this problem is asking us to find. Is it asking us to find an answer to a system of
No,
equations?
it's winning the number.
No, it's asking us to find two numbers. And if I said, okay, class, what are the two numbers? What's your response?
5 and 2.
5 and 2, 2 and 5. So that's the only thing we need to do for our answer. Our answer is 2
And 5?
and 5. We wrote a system to help us find those numbers, but this problem did not ask us to solve a system. So we don't need to write it like the answer to a system. It's just asking us to find two numbers, and we would just say 2 and 5. Do you see the difference on that? Does that make sense?
Yes.
Okay.
I know number 2 is going to start out by 3x.
So let's look at this next one. So again, a chunk at a time. So let's read the whole thing and make sure we know what we're looking for. 3 times one number added to another number is 10.
3x.
3 times the first number minus 2 times the other number is 16.
You lost me with the
And
second
we
one.
want to find the numbers.
Lost me.
Right, so reading through that whole thing is like, okay, that's a lot. But it did tell us what the problem is asking us to find.
Find the numbers.
It's asking us to find two numbers. So you could choose whatever letters you want. The majority of my students are going to choose X as the first and Y as the second.
So wouldn't it be 3x?
Okay, so if we start going through 3 times one number, 3x. Okay with that?
Yes.
Yeah.
Added to.
Plus 10.
So plus another number.
So plus 10. No, y.
Plus Y, because that's our other number,
And then equals 10.
equals 10. Nope, number 2.
Plus.
Okay, now the sentence ended. We're starting a new sentence, so if we're starting a new sentence, what should we probably be starting?
3x.
A new equation.
Mm-hmm.
Okay, so now we have 3 times the first number.
So 3x.
So 3x, because our first number is x,
And then plus y.
minus,
Ah!
so minus, we want subtraction,
Minus
2 times the other number.
2y?
Mhm. Is 16.
Yes. I didn't read that carefully.
Oh, wait.
You could do elimination here.
Yep, so we have that nice neat stack look again. So I'm guessing we probably would agree that we want to go with elimination.
I'm gonna start with the y.
Okay. So if we look up here, Axel, where do we see a matching coefficient up here? The 3. So Axel, are those both the same sign or opposite signs?
Same.
So if they're the same, do you remember what we want to do?
You have to multiply it by what?
Not positive 1, but
Negative.
-1, right? So they're the same sign, so we're going to multiply by that -1. We could also multiply that top equation by 2. There's not a right or wrong answer there. We're going to have to multiply an equation. So let's see, our top equation stays as 3x plus y equals 10. That negative is going all the way through on that bottom equation.
I have a question. Does the x have to be first in your, like, whatever?
Oh, so like, could you say 3y plus x equals 10?
No, like,
Oh.
for your answer, could you do, like...
Oh, yeah, you could go either. So now we can add. Our x's cancel.
Yeah, so 0.
So y plus 2y gives us
3y.
3y. 10 plus -16 gives us -6.
Then we divide. Then we have to plug it back in.
We'll have to plug it back in.
2x. Y.
What letter is this?
Oh, y. So we
So we're
put-
plugging it back in for y.
It would be...
So then,
Yeah, y is a confusing variable because then you can't tell if I'm asking the question why or
Yeah.
why, but we're plugging it in for the letter y.
So 3x plus 2y? Or just 2?
No, because the y goes away, but -2, right?
Okay, yeah.
So 3x, instead of writing plus -2, are we okay with me saying just -2?
Yeah.
Okay with that? We'll solve this.
So it's 4 and 5.
No, what's our other one that we saw over here, Caleb?
4
Oh,
negative.
4 and -2.
Uh-huh.
Sorry, I got mixed up with all my numbers.
Yeah, that's okay. Okay, so here's what I want you to do next. I want you to take a minute. I want you to read number 3. And I...
That's why.
Oh, because you're writing up a row ahead. That is why you were getting confused. Okay, so I want you to take a minute. I want you to read number 3. And I want you to try and write the 2 equations. Don't start solving. Just try and write the 2 equations. Okay, write that system.
What? 3 times. So it's 3 times.
So 3 times one number is good. Equals. So what do we do next? Yeah, don't put it after. Put it right in line. Stick to the exact same order that you read it. So if you go a chunk at a time, you're literally going to write it the exact same order that you read it. So we read 3x, so we wrote down it. Equals, so I write down equals. Twice, what does twice have to do? What number should I write down? 2. A second number.
plus y.
Does it say plus anywhere in there? So don't put plus.
You say 6.
Exactly as you read it.
Twice the first number. What did you say?
Okay.
I said 6x. I know it's twice the first number.
Okay, right.
Where do you say twice?
Okay, so here we go. A chunk at a time.
I don't like the wording in this sentence.
3 times a number.
3x.
3x. I think that was the one piece around the room we could all agree on.
Mm-hmm.
And then all of a sudden we decided it wasn't matching the format of what we've done before, and we freaked out. But class, remember, it doesn't have to. Elimination is stacked, but all the other options aren't necessarily.
I'm thinking this.
So it doesn't mean it has to have an addition sign or a subtraction sign after it. Read it in the order that you read. Equals. What are we writing for equals?
An equal sign.
Twice
2y.
a second number.
I didn't understand that
So twice means to multiply by 2.
though.
I got that.
Okay? Twice is just multiplying by 2.
So
Sentence ends. We see a period. So when we start a new sentence, what do we need to be doing? Starting a new equation.
So would this one be 2x since it says twice the
So
first number?
twice the first number is 2x.
Okay.
Why 6?
Where do you get 6x? Twice the first.
No. The first number isn't this. Remember, x is our first number, and y is our second number.
I was thinking 2 times.
So once we finish this, like this is done. We're not going back to it.
So wouldn't it be
So twice the first number is, what are we writing for is? Equals
3
3. So what am I writing down for 3?
3y?
3, just 3.
3.
Okay, more than. Addition. More than is addition, so I'm going to put an addition sign. The second number,
Y.
y. Sentence is over, equation is done.
You substitution.
Yeah, substitute.
Okay, so right, this is an elimination. That should pretty much jump out at us.
I'm happy it's not.
So, yeah, but do we see a variable that says x equals or y equals?
No.
No, but can we create that?
Yes.
Yes, where would we create that?
I'm not a big fan of
Right here, I'm hearing you say solve for y,
it.
right? So that's the y we need to solve for. So how do we move that positive 3?
Change it to a negative.
Mm-hmm. And so we really have y equal, yeah, I'm just going to write it in the other order, it's fine. I accidentally wrote the y first, but whatever.
So it'd be 2, the way how I want to write it.
2x minus 3 equals y, yeah. Okay, so now this is no longer what we need, right? We need this new readjusted one. What are we going to circle?
Y.
And what are we going to underline?
2x minus 3.
Because when we substitute, right, we circle the variable by itself. We underline what it
Is
equals.
that why you did y first?
Yeah, but you could go that way and it'd be fine. Does it underline? Okay, what letter did we circle?
Y.
So what letter do we need to cross out?
Y.
So up here I'm going to cross out y. And in its place, what am I going to put?
3x
times
equals-
2x minus 3.
Okay, so I'm putting that 2x minus 3 in its place. How important are those parentheses?
Really important.
Really important because there's a coefficient in front. So our new equation says 3x equals 2 times 2x minus 3.
Okay.
So to solve this, what are we going to do?
2 times 2.
All right, we're going to distribute and get a 4x minus 6.
So then, this, yeah, 3x.
Are those variables on the same side or are they on opposite sides?
No, but if we do, we have to do minus 4 because if we do the minus 3, it'll be 0 and it'll make it harder.
Right, so we can subtract the 3x. It would be fine. We're just going to move stuff back over there. So subtracting the 4x might just make it a little bit easier. But they are on opposite sides, so we definitely have to use the opposite sign.
Why wouldn't you subtract the 4 to the 6?
Because one's an x and one doesn't, right? These aren't like terms,
Oh, I didn't see the x.
right? So these both, oh, did you forget to write that x down? So this is a negative 1x equals a -6. Divide by -1,
It'd be
That's
6.
gonna be positive.
which makes it a +6.
We have to plug it back.
But are we done? Nope, we need to plug it back in. Where in substitution did we say was the easiest place to plug it back in?
Where
Where we underline.
Where we underlined.
So it's y equals 2 times 6.
-3.
Yeah.
So what is 12 minus 3?
Give me 2.
9.
9.
2 times 6 is 12.
Yeah.
No.
So we get y equals 9.
Mm-hmm.
So what is our final answer going to be?
6, 9.
6 and 9. We don't have to write it as a
No.
system because it's just a story problem.